All right, so now we're going to be doing a binary thing, a binary tree node. Basically, roots are like the very start. So the way to visualize this is like imagine you're doing a binary search. So like you have every number from 1 to 100 and then you search first in the middle, so you'd say 50 and then if they say too high, 25. Eventually, you'll reach numbers that are like at the very end. Those are called leaves in this example, and then those are the numbers where it's like the worst case guesses, I guess, where like you kept searching. So there's two ways to do this. The first is you could do a log on how big the array is, but that assumes every single number is in here, so that doesn't work. And they're giving us a table parent. So it's really easy to see which one the root is because it's going to be where the parent is null. So we can go ahead and just type that part already. So the first thing is we're going to be doing an if statement. And what is the output they want? They want the ID. So they want n. What is the table from BST? From BST. Okay. So the first thing is there's two columns. So we're going to select n. Here, let's just run this. We'll see what it looks like. Make sure everything's going okay. Yep, we got all our numbers. Perfect. So in order to do if statement, I'm going to use a case. I don't know of another way to do it. Oops, spelled that wrong. So let's do the root first because that one's pretty easy. So when BST do we need to write BST dot or can we just write when P is null, then is null, then root. And then we're going to do else inner because we already know that we're not going to deal with this later. We're just going to do root, leave, and then inner. Run code. Oh, I need to end it. Oops. Okay, so look, we got everything to print. Why is 15 the root? That looks a bit off. 15 should not be the root. I'm doubting myself now. Let's comment out everything and then just select the table so we can get a full picture of what's going on. From BST. Oh, Control Enter does not run code in Hackerrank. Okay, I'm a little lost on why 15. Well, I guess it doesn't. Okay, so I guess I was wrong on how it is like a binary search. In this example, it was like a binary search. But in this example, I guess they're just branching things off randomly. Or I'm not understanding something. How do you do a one-line comment? They're going to tell me, oh, dash dash. Okay. I'm very used to how Snowflake lets you do dash dash to comment things out. Okay, so now we have to figure out how to find the leaves. So the best method is to see if the leaf does not exist in column P. So MySQL how to see if item does not exist in different column. Not exist, not in. Left join is null. We don't need to join anything because they are already in the same table. Can use an alias to stimulate a join. Quest. Let's just do not exist. This is going to confuse me, even though I'm pretty sure it works. I think this is the same. What does it say? Recommended for performance. Well, this isn't production grade. Okay, so where does the select ends? Oh, okay, so it's a not. So not exist basically just runs a query. I see. And then when, because that's a condition. Why not exist? Select one from. Everything is from this table. We can just call it T2. It's fine. Select one from T2 column B. So what is it? P. So parent column and node column. What is T1 and T2 here? Okay, so this also kind of joins to tables. I guess it just does it cleaner. You have an error. Else inner. Oh, I forgot to add then what? Then leaf. Great, it thinks everything is a leaf. Does that work? No. Why is this becoming a catch-all? Select one from BST. All right, let's ask why this is not working. There sometimes are like minor syntax things. I mean, are they? Yeah, they are both integers. And we ran the select all. No, root is classifying correctly. Okay, I think the issue here is that we were supposed to separate BST into like two tables to like kind of stimulate a join. So let's see. We'll call it 2. Think you can do any name. And then we're 2 dot. So we're the parent. And 2 is equal to, is this right syntax? Okay, let's just completely separate out the two tables. So, okay, I was going to call it parent and leaf, but that would just make this incredibly confusing. So I'll just call it in and out. So this is in. Oh, that's a reserved keyword. What about I? Okay, and I'll call this out. So o.bst, and then we'll call this I because this is the inner one. Select, and this is out when this one is also out. It's, are you out of the second, it's only for the second condition, or are you in it? I think I'm going to get a syntax error. Nice. Why is this wrong? Let's read the question. Maybe I missed something. Root, leaf, inner. Spelled those correctly. Oh, it wants it ordered by the value of the node. MySQL sort. Oh yeah, there's like a sort by command. Yeah, sort by something ascending. Sort by o.p. You have an error. Oops, I meant to say o.n. You have an uncaught error. Sort by. Nope. Oh, sort is not a keyword, it's order. Okay. In Snowflake, it's sort. I don't know why MySQL uses order, but I mean, in a perfect world, both keywords are acceptable, right? We accept everyone.